Hello and welcome everyone to today's episode. Today we are going to be covering the following topics. All the timestamps are in the description below. And I hope you enjoy today's episode. So let's get started on these topics. Let's take a look at set operations in C# using LINQ, which is short for Language Integrated Query. So here we have list A and we have list B. And as you can see in list A, we have Alice and Alice twice. And then we've got Bob and Bob here. But some, such as Eve, doesn't appear in the first list. And so does George. He doesn't appear in the first list. And then David appears in list A, but he doesn't appear in list C. So David is not here. Now we have duplicates in here. So what we want to do is in list A, we want to remove duplicates. So we use the distinct method here, and this will remove the duplicates. And then we can just loop through the distinct names, which is the variable here, and just output the name. So if I run this code here, so as you can see here, distinct in list A, we've got Alice, Bob, Charlie, and David. So you can see Alice appeared twice here and has now been removed. Let's have a look at the union method now. So what this will do is combine list A and B and remove any duplicates. So we're giving it list A here, and then we've got list B here in the parentheses. And then again, we have our loop and we're just going to print the names. So this will remove duplicates in both lists. So for example, we've got Bob here and Bob here. This will remove the duplicates. So we'll also remove duplicates in the first list. So Alice appeared twice, so she should only appear once. And so does Charlie and Charlie here. So here's the output of the union. So as you can see, we've got list A and B. We've got Alice here, Bob, Charlie, David, Eve, Frank, and George. So they have been merged without any duplicates. Now let's take a look at intersect. Get common items between list A and B. So here what we're doing is we've got list A, and in the parentheses we are passing it list B using the intersect method. So what this will do is get the common names. So here, as you can see, the common names are Bob, Bob here, Charlie, Charlie here. Because Alice doesn't appear in the second list, she is not common in both lists, so she should not appear in the output. So let's have a look at the output. So the common names in list A and B are just Bob and Charlie. So you can see all the other names such as David, George, Alice do not appear in this list here. Now let's take a look at except. So what except will do is it will take the names in list A that are not in list B. So again, you can swap the order of this. So you could add list E here and list A here. In this instance, what we want to do is names in list A that are not in B. So the except method is taking list B. I'm going to check to make sure they're not in there. So the names that are not in list B are Alice, save it. So if we have a look at the output here, so you can see names in list E but not in B. So we've got Alice and we've got David. So I hope you found the following set operation distinct: union, intersect, and except. So again, just to repeat, distinct will remove all duplicate elements. Union will combine elements from both lists and remove duplicates. Intersect will only show the common elements between both lists, and except will only show from the first selection that are not in the second. Or you could reverse that as shown here. You could reverse this, put list B here and list A there. So I hope you found this explanation of set operations useful. Let's have a look at some functionality of list objects with LINQ. So here, what you can see is they are creating a people variable here, and this will hold a list of person. Person is a class. So you can see person is this class. It has a name and it has pets. Pets in itself is a list. So what we're going to do is we're going to add the first person. So new person, Alice, and then her pets are going to be a new list. And the pets she's going to have is Max, which is a dog, Milo, which is a cat, and that's Alice done. And then you've got Bob, Bob's got Charlie, the cat, and then Charlie is a person, and he has 3 pets, Buddy, Lucy, Mittens, and then David has no pets. So you can see a new list is created, but nothing is assigned. So one of the things you can do is check if any of these people actually they have a dog. So here what we're checking is pet type equal to dog using the any method. So we're checking people.web. So this is again a LINQ method. We're passing key here. What is P? Basically, it's the original object that you have here, people. So that's the variable. And within that, each person has a property called pets. And we're checking if any, so then anything in our list of people, do they have a dog? If they do, then that basically will give us, dog owners. Then we're going to just simply loop through those people that we found, and we're going to print out their name. But the next thing you could do is people who have more than one pet. So we are going to again use the where method here. We're going to use the people object here. And what we are going to do here is use the count property on the list that is pets. So where does pets come from? As you know, in our class, when we created it, pets actually is a list. So a list has a method called count. And what we're going to check is that count greater than 1. If it is, then we want to include those people, and this would be known as multi-pet owners. And then we have another method here, which is a bit more complicated than before. But what we're using is SelectMany, and we are going to use key. Key is basically your people object, and we are then going to extract the pets from it. Pets is a list, and then we are attaching on or chaining a where method to this, and it is going to check if the individual pet type is cat. If it is, then we want to select the pet name. So out of all the people that we have here, so all the people, we want to extract the pets list, and then we want to check if any of those is of type pet, and then we're going to simply select the pet name. And then once we have that, this will be a flattened list. So just imagine you have a situation where this is your list, and you previously what you had was a list within here of different pets that each person owns. So that's one. So that's one person there, and then the second person would have their own pets here. So we've got 3 pets here, 3 at the top, but these are 2 different lists here. But what the SelectMany does is it basically extracts out the pets only and puts them in the overarching list object over here, so you can access it directly. And that's why when you look at this bit over here, which is we're looping through the cat names, it is actually just referring to this one over here rather than the one with nested lists. So that's what SelectMany does. It basically converts this structure into this structure over here. And then people who have a pet named Max. So here again, what we are doing is we're passing the people variable and p.pets, and we're checking if any pet name is Max. Then we're just simply going to write out the person name who has the pet name for Max. So if I run all this code, so here you can see that people who have a dog, so Alice and Charlie, people who have more than one pet, Alice and Charlie, all cat names, so these are all the cat names of the pets, and people who have pet name called Max, and that's Alice. So I hope you found these different methods where LINQ can work with list objects, and this becomes really handy and quick to do some complex logic. SelectMany is one of the hardest methods to understand in LINQ. So let's see if we can make this easier for you to understand. So as you can see here, SelectMany starts here, and we can chain other methods to it. So this is the first part, and then we are chaining a where to it, and then we can chain select to it. So what's happening is with this SelectMany, what it's doing is pets is taking that pets and flattening the structure. So what I mean by that is if we have a look at this people variable, and you can see the people variable actually is very top of a class person, and this is a list, so it will contain a list of people. So if we have a look at that, what is a person? So a person is here, and they can have a name and they can have pets. Notice the pets in itself is a list, and this is what the pet actually is. It just has name and type. So if we scroll down here, so the data structure is a new person is created. Within the new person is a new list of pets. So a person can have more than one pet. I think Alice here has Milo and Max, 2 pets, while here Charlie has 3, Birdie, Lucy, and Mittens. So we have 3 pets here, and some will have no pets. So what we want to do is we want to expand only the pets. So forget about the people. We just want to expand all the pets together in a nice list. And this is what SelectMany does. What it's doing there is taking the people variable. So people.pets. So p is just short for people, and we have decided to call it p, and it's going to take the pets of everyone and convert them into a single list. Once we have that single list, we can then apply the where method, and for that we're just going to select the type of pet to be a cat. So then after that we select chain another method on, which is select method, and we just simply select the pet name. Now at this point we just have enumerable list like structure, so we can just loop through it and print pet's name. So in essence, that's what SelectMany is doing. It just converts a complex embedded structure into a simple list. So imagine we had different people here, 1, 2, and 3. Within each person, there is now a list of pets over here, and we're here, and then somebody with no pets, for you could have 3 pets over here as well, and then we could have another one with no pets. Now our data structure looks like this. It's a list over here. So this list has people in it, and within those people we have a list of pets. So what SelectMany is doing is extracting that, and that. So it's extracting the 3 lists within each person from the outer list. So then we just end up with structure of just pets. So you just end up with a pet structure here where you've just got a list of pets rather than something like this, which is embedded lists. So you just end up with one simple list object like this. So then you can just simply query this list here with type equals cat, and that's what we are doing here, which is we're just checking once we have this list here, we're just checking the cat, whereas trying to look for the cat within here is a bit more complex. So I hope this makes sense with SelectMany and what it's trying to do. Change list of lists into an enumerable structure, which is like a list, so that you can easily query it and output it using a simple for each loop. Let's make it a bit more interesting. So we have SelectMany here to extract pet name. So here you have a person called Alice. Alice has 2 pets called Max and Milo. So it just extracts the pet names from all the people and prints them out. But an interesting combination I want is I not only want the pet name, I also want the owner name to be printed next to each pet. So how do we do that? And you might say, well, actually what you can do is you can just add, we know the people object there, p.pets. So what we can do is we can just access owner name. And as you can see, IntelliSense doesn't detect that p. It says there's nothing called P. If I do that, you can see it's saying P does not exist in the current context. So how do we solve that? You can see each method is chained on to the SelectMany, but what if we remove this bracket and instead put it down here, move it from over here to down here? So essentially you can see it was there, and if I remove that and put it here, what's happened is it's changed the structure. Now SelectMany starts over here and it ends over here. So all the code within here has now become part of SelectMany. So that does mean I can now access the P variable there. So you can see it's now available over here. So if I do p.name, I can get the person's name. But then we have another issue to say that this won't work. The reason this won't work is you try to output two variables with the select operator, and that's not allowed. So what you need to do is create a new object, an anonymous object, or it could be a named object. So here we're just going to add the word new, stick these two properties that we have in the curly braces here. And now we got an error to say an anonymous type cannot have multiple properties at the same time. So what we need to do is need to change the name of one of them or both of them. You can change the name of this one, for example, this to call it person name and make that equal to that. Or you can actually give a name to this one as well. So we can just call it pet name equals. And our code here now works. There are no errors. And then in the loop, this is now an object rather than a simple string. All we need to do that is an item. So we'll just call it an item. Then we're going to change this item dot. We now get the two properties of pet name and person name. So what we'll do person name first. So here what we have is person name and pet name. So item is our variable here, and we're just accessing the name value. So you can see here we now have Alice is the owner of Milo, Bob is the owner of Charlie, and Charlie has pet called Attens. We can create a new anonymous object and not only use the pet name but also use P name. So essentially what we have done is we had a list here. Within the list we had a list of people, and then within there we had a list of pets individually. And what we've done is we have extracted the pets over here, and we have extracted the name of the person over here, and we have just put them in a single list like object, enumerable list object. This is what you get. So you basically get the person name and their pet, person name and their pet. So then you can easily loop through. So here's the object here. So this object refers to this. So we can just loop through that using for each, and we can just print out person name, and we can then also print out the pet name. Let's have a look at another example of SelectMany to understand what it's trying to do. So here I have a store, department and products. If I go up here, so you can see what it looks like. So you can see what it looks like. So here I have store A, and within store A there's a list of departments, and then within the departments there is a list of products. So you can see this is store A and department produce, and within the produce department you have apple and bananas, and then here we have another department dairy, and you have milk and cheese. Then we move on to store B. Store B has a bakery in it. Within it you get bread and bagels, and then you've got personal care as the new department, soap, shampoo and toothpaste. So here what we're going to do is we've got the SelectMany, so we're going to select the store here. So this is important. Store is then we are passing the departments within each store. So we have the store details here and then the department, and we're creating a new object out of it using the lambda operator here. So here you can see we're taking the store name. So this is a new anonymous object, and we're saying department is actually equal to department. So what is department? Department. So this depart, the EPT comes from departments, and then what we're doing is we're just making this equal to departments over here. So this EPT comes from here. So first it gets transferred over here, and then we transfer it over here. Store is basically we're putting the store name. So this is actually store, and this comes from here because chaining the method. And then next we get an object, and that object we just call it X. So this is now another chained SelectMany, and we get the department. So that's what we called the variable, and we're extracting the products. And now notice we are again passing the X along, and we're creating now per product. So per product using a lambda operator, we are creating a new object, and that new object is the result set. So here the result set will have the following. Name comes from X because that's where the store name lives. Department name again comes from X. So remember we had X. So here this object is anonymous. So here we have X.department department.name. And then we have the product name, which simply comes from product.name, because we decided to transfer the products over here into this variable, so they're accessible through product. And then we can simply loop through our items here and print the store name, the department name, all from this item variable, and also the product name, all from the item name. So what this has basically done is we had a list of stores within them list of departments, and within them list of products. And what we've done basically is flatten them. So what is the purpose of SelectMany, and why are they different to Select? So let's understand this in more detail. So imagine a situation where you have stores, and within those stores you have departments. So here you can see stores, store A, store B. And then within store A, you've got the produce department and dairy department. And store B has bakery and personal care. So how do we get from this list where we want to extract just the products with the department name, with the store name? That's where SelectMany comes in very handy. So what it does is it takes this nested list products, flattens them so they become like this. So you've got store A, then the department, and then Apple, then the product. You can see here, we went from here to here. So how do they accomplish this? It does this by first using the store variable and then applying the SelectMany method on that, taking the store and passing the departments to the separate object. So it's separating out the departments within a store like this. So that store A is separating that out, like here, store B separating that out. So now what we have is we have store A being separated from its department. You flatten it. So once you have that, we also want to carry the store details, so such as the store name. So here we are carrying the store name and then the department. So what does department contain? Department contains the following: individual department name, and then within the department you've got apple, bananas as the product. So once you have that, we now have a new anonymous object that contains this information. So imagine now at this point we simply have a structure that looks like this. Store A, but it's no longer in a hierarchy. You can see already store A has just become a label, and that's what we're doing. We're just getting the name of the store, and we're applying the same concept to the products. So now the products are being separated from the department, so it becomes like this, and the department itself becomes just a label over here. So we're just separating that out over here. So the hierarchy element is now disappearing. So now the only hierarchy that remains is the products themselves. So once we have this new object, which we're calling it X, you can call it whatever you want. We're creating a new object out of that, and we're just getting individual product names, individual department name, and the store name. The store name has come all the way from here into the X variable here, and it's still accessible and in scope here. But it's all about scope. So we're just passing the store name along different points using whatever mechanism or variables that we have. But when we get this, remember this is the next SelectMany, the chain method, so it can access the objects created here. And because this object we've decided to call X, it's carried forward, and we can then access its properties. So X here, you can see it's being passed along once more, and that's why it's accessible over here, because it's being passed over there. So that's what SelectMany does. Essentially, you go from a hierarchical list like this, store A, store B, within stores you have departments, and then within departments you have products, and all we're doing is we're just flattening that structure so we can repeat the store name and the department next to each product. But then it becomes a simple list that you can just loop through. So if I run this code here, you can see this is the output that we get. So we get store A, department, and then product. This serve structure, and that's what you can see in the code as well. So here you can see how it's structured. So we're creating a store, a produce department. Within the produce, you have list of products here, and these are just classes. So the class for the product has this the name, class for department has name, and then a list of products, and then store, of course, it's just a list of departments, and it has a name as well. So I hope this makes sense in terms of SelectMany and how you can use it to flatten your hierarchies. So how many levels can SelectMany actually flatten? The answer is it can only do a list of a list. So essentially 2 levels. But when you have a situation like this, which is a list of a list of a list, then you need to use 2 SelectManys. So use them twice rather than once. So let's have a look at what we mean by this example. So here you have a list, and this list has 2 items. So that's your first list, which is we've got 2 items within our list. And then within the individual items, we have 2 more items. So this is a list of a list. So if I run this code, so you can see we get the output something like this, which is flattened those lists. Now, if you didn't flatten this list, so what would actually happen if I just do a select on it rather than SelectMany from this code again? You can see that we just get the date type of the item to say it is a list. You can access the individual item because it is a list, so you can access it like this, and this would give you the same output as we had before, but you can see we've accessed the individual items over here. But notice we have only access to the first element, so A and C. So you can see A and C. But this is not what we wanted. Instead, what we wanted was to print out all the items within the inner list. So that's why you need SelectMany here, and this will give you the output that you want. So here you can now see I have a list of a list of a list. So we have 3 lists here. So you have a new item here. So there, a list. And then within the list itself, we've got 2 items here. So that's your second level. And of course, then you've got the inner list here, which is the items within this list over here. So in order to flatten them, you need to use the SelectMany twice. So first you do the level 1 and then level 2, and then you've got access to the items within these lists. If I run this code here, you can see that we've got the items there. Now, if I didn't use the second SelectMany, so if I commented that out, I run this again, and you can see what we get is to say there are 3 list items. So why do we get these 3 list items? So if we have a look here, so you can see that it's flattened 1, 2, and 3. So it's flattened them, but it hasn't done the next level because that list, these 3 items here are actually lists because they have multiple items within them and they are of type list. So that's why we're getting 3 items here. They're just referring to the individuals over here. So in order to flatten them, you do need to use the second SelectMany. So only because otherwise the level's depth would be reduced. So here, if I run this again with 2 SelectManys, and you can see we got the desired results that we wanted. So if you end up in that situation, just make sure you use the second SelectMany to go 1 level deep. And if you've got more hierarchy, you can add more SelectMany. Check out my other explanations, which use classes as examples, and they're really useful for complex situations. So make sure you like and subscribe to for more explanations like this. So how does SelectMany work internally? So this is a simple explanation and not exactly how all the internals work, but just to give you an idea. So here what you have is a source. So what is the source? Source could be a list of students. Those list of students could have hobbies, and they could have multiple hobbies. For example, John could have a hobby of reading and swimming. So those 2 hobbies are a list because John has multiple hobbies. So here's the source, and then you have the selector. What the selector is doing is now it's got the list of hobbies, and for each inner list we have the inner item, which will be the individual hobby. So the first one will be reading, and then we return that back. So then what you have is student, which is John, has a hobby of reading. Then you loop through the next item, which is swimming, and swimming would be the next item, and then you return that using yield return. And then after those are done, then you move on to the next student in source. So the next student could be David. David would then be selected, and then his hobbies would be selected here, and then we do the same thing, which is loop through his hobbies, and then after that is done, we return to the next student, and it continues like this. So this is how it's working internally using the yield and the return methods. So I hope this gives you an idea of why using the SelectMany is better, so you don't have to write all this code yourself. C# has anonymous types where the type is inferred. So by using the var keyword, infer a C# type. So here we are creating a person variable that doesn't really have a type. What this is doing is creating a new anonymous type. So this would be an object that is similar to a class that has already been declared. So here you have a name, age, property, but there is no link to any class here. You're just using the new keyword. And this would still create an object in C#. If I run this code, so here you can see that we do have the output of John from our code here. And it is important to understand that this is not really a type. Anonymous types like this with the var keyword are used commonly using LINQ. So here we have a LINQ method of select, and this is projecting a new object. A new object has name and grade. So you can see here we started off with an anonymous object over here, and that anonymous object has 3 properties: ID, name, and grade. And then using LINQ, we are creating a new object and only selecting the name and the grade properties. And this is giving another new anonymous object, and we're storing that in that variable. And then we can loop through that anonymous object and print out the properties. So here you can see we've got Sarah, John, and Ali. And here you can see another example. This is where we are creating a new object or projecting a new object. So again, we're using projection, but we are using a calculated field here. So the status field is actually a calculation. If the grade is greater than 90, then we're going to say it's excellent. Otherwise, we're going to say it's good. So here we're using a ternary operator as it is easier to read. So this would be if the condition is true, and this would be if the condition is false. So if the grade score is greater than or equal to 90, we say excellent. Otherwise, we say good. So this is a calculation calculated rejection. And here you can see the output. Sarah is good, John is excellent, and Ali is excellent, because this is their equivalent scores. Now, another projection is you can also use the index of the item. Index is available for most objects. So here what you can do is set any anonymous object, index is equal to index plus 1. Plus 1 is needed because indexes are 0 based. So for index 0, we're just changing it to 1, and for index 1, we're changing it to index 2. So again, this is creating any anonymous object, and you can see we have the output here where I'm printing the index at the end. So Sarah is 1, John is 2, and Ali is 3. So these are some of the practical uses of anonymous objects, and you should be familiar with the syntax. Whenever you see a new keyword without variable type, such as this, then you need to assume that it is anonymous object. And when you see the var keyword, you need to assume that the type is inferred, where C# compiler will try and work out the type. If it can, for anonymous objects, it will just create something internal to track that object.